Yes, we welcome you to the webinar series, and we'll talk about attention today. And I also welcome the people who watch this afterwards or watch it online. And we'll be recording this, and you can leave comments and questions in the F&A section, the Q&A sections, and me and Neil will be happy to answer them. What we'll do today is that I'll start a bit and give you an overview about the methods and tools, how we do applied research with eye tracking. And since we have a guest today, I'll try to keep this part short and then invite Neil into the session here with us. And let me share my slides first. Take it from here. So in the first part, we already discussed some of the foundations of human visual attention and why we measure it and where it comes from the evolutionary perspective. I'll repeat maybe one or two slides of this, and what we want to do today is focus on our guest in the second section and learn about Pupil Labs and all of their great developments and their great product. And since it's already late, where Neil is dialing in from Hong Kong, actually, I'll be happy to invite you into the session. Just a second, Neil, and let me turn on my pointer here. So what we'll speak about the methods, and I'll give you a brief overview about the eye tracking systems that we always have used in the last 25 years and how this changed. And in the next sections, we will talk about AI prediction and also compare these two and the real applications, where we'll dive a bit more into how we use eye tracking. So the prediction part, since it's so interesting for everyone and people are asking us a lot about, is how we compare it. Is it either or? That's something we'll discuss and show examples too. Hopefully also have a guest speaker in the application part. Yeah, most of our eye tracking we do in the ads section, the media section, the shopper section as well. And in the UX field, eye tracking also plays a vital role. So we'll have a look at these in the next sections. And since iSquare has been doing eye tracking since 25 years, and we have used it in so many variations and settings in the applied sector, we always want to stress that it's a method that we combine with other methods, and we also love to talk and write about. So this chapter here, my colleague Matthias and I wrote 2019, actually. It was the neuromarketing chapter in the eye movement research book from Professor Klein and Ettinger. And this year there's a new edition coming out, and actually the chapter will be marketing. So how eye tracking is used in marketing. And so this is quite interesting for us to also see even what has changed just in the last 6 years. And I'll give you a couple of examples. And one important part for us is always that we have to think about what does influence our visual attention. And in the book, we cited Riedel and Peters here. And it's always these three parts. The strongest, you could say, is probably the bottom-up, the stimulus-driven factors, and then our individual factors come in as well. Our top-down, exactly what I have in mind, how I grew up, what's my motivation, what have I learned, and the exposure situation. And when we do eye tracking analysis or use methods, all three of these always come in. And if we also look at eye tracking heat maps or analysis like these we've done in the shopper world, we also always have to think about, okay, what was the task here? Did people have to buy something particular, something healthy or not? Or did they just look at the picture? Or did they actually have degrees of freedom or not? And the task instruction and what um, what the setting was, even which eye tracking system we used here. That's all, of course, relevant questions, and that's what we're gonna look at today. So looking back, can definitely say that eye tracking has, has grown and grown up, and the question isn't, you know, whether to measure attention. It's actually um, which method does fit your question. Is it maybe even predictive eye tracking? Is it head-mounted eye tracking? What is the best setup? And yeah, also looked at all the old assumptions, that eye tracking always needs expensive hardware. Sample sizes are too small. It takes weeks to get the results. Only specialists can interpret the data. Wearable eye trackers are clunky, and only desktop eye tracking actually works. And all of this has actually changed a lot since the algorithms have been evolved so much, even for webcam eye tracking, for the smartphone front-facing cameras algorithms. And so there has been a lot of changes, and in the media world, especially in the last 6 years as well. So durability and active attention, programmatic integration, financial correlation, these industry standardizations that we have seen in the last 6 years when we wrote the first chapter of the book. It's amazing what initiatives have come up, and also the scalability, machine learning, AI sector has evolved, of course, so rapidly that eye tracking now has become like a computer vision, cloud computing expert field, and a lot of the part that we have usually done on one machine, one laptop now is actually moved to the cloud. So the whole industry changed a lot. And what we promised you today is an overview about the methods. And when we look at our archive and look at the eye tracking videos, you can see the settings are super versatile. Here we see in-car research, more UX based. Here we see eye tracking on mobile phones, social media, um, print, advertisement testing, definitely moving images, TV research, shopper research on the shelf, at the point of sale as well. You will see it's a German supermarket, and this is a US supermarket. You see where eye tracking then is used actually in the wild, we say, and how many hours of videos we analyzed in these different settings, and we differentiate between these systems. So originally, we just had remote eye trackers that are attached to the computer screen, and we had the head-mounted eye trackers. And here we can say they're both professional equipment, and the infrared based, where actually little infrared lights are directed to my eye, so I have a reflection point, and so that the measurement is actually very accurate. In contrast, these consumer hardware eye tracking, webcam or smartphone eye tracking also came in. They changed the field a lot, and they kind of rely on our human eye, that we have the sclera, the white around our pupil in our eye, that enables good quality cameras to see where I'm looking at even without infrared. And then the latest, I think, the field is the predictive AI eye tracking, where algorithms are trained on human attention data and on saliency data, so where that human attention can be predicted. And that's of course a field that's growing fast. And yeah, the lab-based eye tracking has declined since obviously the last 5 years. And so the infrared eye tracking has the restrictions that we always need to invite people to a lab. And so the sample sizes and the costs are higher. Um, Head-mounted eye tracking, of course, is professional equipment. We'll talk about that with with Neil as well. Here we have the advantage that the costs have lowered a lot and the ease of use has dramatically changed. So we can send actually a, a pair of Tobii or Pupil eye trackers. They're connected to a normal smartphone and can send it to people's homes, and they can immediately start the eye tracking even without an expert to help them. Smartphone and webcam eye tracking uses consumer hardware, so here we definitely take the advantage of inviting people into our research studies, so hundreds of people in one night, and the calibration is then just simply done on the smartphone or on the computer screen. No need to install anything anymore. Accuracy, of course, is not comparable to an infrared system, but through the larger sample sizes and the great training algorithms, things have gotten a lot better and actually improved a lot. And the field of eye tracking partners, vendors, suppliers, and platforms is vast. It's always changing. So this list is definitely not complete. So the remote screen-based eye trackers have the highest precision. The controlled environments are needed. The wearable mobile hardware gives you a lot of degrees of freedom. So we use them in cars, on second screen research, when people are at home and looking at their phone and their TV. The smartphone helps a lot since we can invite people around the world to participate in studies in virtual context, and same with the webcam and the remote predictive eye tracking. The fast screening part where no participants actually need to be invited are super interesting as well. The analytics and data platforms like iMotions or Lickshift, Tobii Lab also help a lot to not only record the data, but also to analyze it. And in our field where we do a lot of the applied research, the control of the environment, so what the people see has an important part of this too, especially when we talk about smartphone and webcam. We need to control what people will look at in their browsers, just even to be able to analyze things overnight and not having to look at every video. And so actually this combination of the context and the eye tracking, or being able to automatically analyze what has been looked at, scrolled at, or has been in the field of view in the shop, that's where the things get interesting. And that's also where Neil comes in, because that's where the Pupil Lab team is so good at. So when I introduce Pupil Labs, I always have to think of how I met Moritz and Will first when they came from the MIT where they met, and they did a research project together where they just built an eye tracker just for the fun of it, and then they made a company out of it. And Neil, you can probably tell the story even better. And let me bring you on stage here and give you the speaker rights as well. Just a second. Here we are. Where did you go, Neil?
Hi, Philip. Can you hear me?
I can hear you, but I just made you give you speaking rights, and I wanted to give you, of course, here you are. Yeah, I found you on the list. Sorry, the list of participants was a
Yeah.
bit longer than I expected, and I'll make you discussion participant. And welcome, Neil. It's my pleasure. Thank you for dialing in even
Okay. Let me
in
just
your evening
enable
time. Yeah, take your time. Take your time.
my
We'll just
video. There we
yes,
go.
yes, I can see you, and we can
Great.
recognize you. We still see your picture here. Let me turn off the screen sharing for a second so people can see the both of us. And maybe I'll introduce you properly first. So you are the product specialist at Pupil Labs. You've been with Pupil Labs since over 5 years, and I was just struggling when I tried to remember when it was founded. I think in 2019, right?
Pupil Labs,
Yes.
2014 was when things became serious. Yeah.
Wow, that's
Yeah.
so long ago. Yes, and it was such a pleasure to meet Moritz and Will in those days, and when they started with the truly open source, project and actually using consumer hardware in the early days, like real webcam technology to build an eye tracker purely like Python code and seeing where you guys are now. How would you describe Pupil Labs now? Like, how big are you? Always difficult to put in numbers, right?
Yeah, no, it's a super interesting and great story. Will and Moritz doing a joint master's thesis at MIT. They needed an eye tracker. They were prohibitively expensive black box things at the time, so they built their own for their architecture project, and the rest history really. It kind of grew from there. When we first launched, or the kind of the first eye tracker that started it all, which was Pupil Core. That was, as you said, kind of an open source framework for doing eye tracking, right? You could literally put off-the-shelf webcams onto a frame, and then stream the video feeds into the Pupil capture software, and then do
Right.
eye tracking, right? So it was and still is an open source framework ultimately. But at the same time, it was a very capable piece of kit. In 2004, 14, should I say, the eye track and kind of progressing a couple of years later, they were doing 200 hertz eye tracking, getting like zero point 0.5 degrees of accuracy with this thing. So, really cool. Definitely an industry disrupting system. Um,
Definitely, definitely. Yeah. I mean, I remember we've been using when they were still attached to the laptop, and first it was like a Linux machine, and that was definitely like over ten years ago. And seeing your office in Kreuzberg, and I mean, you're now in Hong Kong, Will is I mean, you have offices all around the world. I don't know how many pieces you sell. That's not what we want to talk about here today, anyways. But I do like to see the curve of the publications as well. You know how many people actually use Pupil Labs and to see in what settings, like how people use it in your blog and in your I think also in the Alpha Lab, you showcase so many cool things. Maybe we'll have some time to look at this since we have you here today and learn a bit about what you have been. I mean, that was just like in the last few months, all of these interesting things that happened. But just about the science part. So your job as a product specialist. So you're basically working with all of the pupil teams together then, right?
Yeah, we have so my team, the product specialists and research consultants, we're kind of involved in a lot of different aspects of what we're doing at Pupil Labs. Um, whether it be producing content, offering consultancy to our clients and users, updating the documentation, doing conferences and things like that. But I think the point that you were touching on there was like the tools that we build as well, and put onto the Alpha Lab, which is, yeah, essentially a section of our website where we see new groundbreaking tools being released. So the likes of your new computer vision algorithms, GPT is suddenly able to interpret images, right? What can we do with that? How can we leverage that? So we try to connect these external tools with our systems, build stuff and put it online for people to use and develop
So
and build upon. Yeah.
the the Alpha Lab is like also where you show stuff that's possible, or is that how would you describe the Alpha Lab? Just for
Yeah, it's a
yeah.
place where we build stuff and connect our tools with cutting edge technology, right? And make it open source as well.
Mhm.
Um, we can maybe go through some examples, but we show how to synchronize and integrate eye tracking with 3D motion capture. That's one example.
Yeah, yeah, that's
Um,
cool. But
yeah.
sorry, I also did forget. I mean, I wanted to introduce not only you and the company, but also the product, of course, the system itself. So from my perspective, of course, Pupil Labs has always been in that way. leading cutting edge because of your guys envisioning, what is open source, what is computer vision,
Yeah.
and how you want to see a modern product. And I think from the computer vision experts, like I mean, you're a PhD as well, but also in the whole team, you have so many people who are expert in that field, and you're connected to the University of Stuttgart with the building. So it's like a highly academic company, I would say, and the product itself, the like what we normally used to say, we actually buy an eye tracker like in the old days, is also an amazing piece of hardware. But from my perspective, is always the software is then where things are happening. But how's it in your company? Do you have actually then the team, the engineering team and the software team, or is it all one
We
team?
we do have distinct teams that like specialize in these areas, but I'd say like you kind of hit a good point on the hardware and the actual eye tracker itself. I mean, our mantra has always been like great technology gets out of your way, right? And so in the old days with Pupil Core, very great, like very powerful piece of kit, but it was a little bit technical, right? You needed to have some operator training and get to grips
Hmm.
with it. Now we've got Neon, which is essentially super easy to use. If you can, as you kind of briefly mentioned in one of your slides, if you can operate a phone and an Android application now, you can actually operate a research grade eye tracker with Neon. It's as simple as connecting it, opening an app, putting the system on, and pressing record. But at the same time, it's a research grade piece of kit, and we're doing many different kinds of data streams. So pupillometry, eye state, optical axis vectors, all of these rich data streams, and then post-hoc analysis pipelines as well, all in a kind of a very, very accessible format. So I think my team's role in all of this, we're kind of advocates for users. I'd like to
Hmm.
think of us um, as enablers of our tech, but advocates for our users, right? So we want to see what's working, what are people's pain points, and then ensure that bubbles up and goes into product development and road mapping through various kind of mechanisms and means. But I think that's the overall goal, one of the biggest goals and mission of my team.
Cool. Yeah. And it worked great. I mean, I remember how we, actually had that dream that a respondent or a participant in our research would be able to, in a way, press record themselves, and we can send a kit to somebody's home and say, please record 2 hours of media consumption. And
Yeah.
this was always our dream, and it did work. So we're
Yeah.
very, very happy.
I mean, it really has kind of got to the stage now. There's so many new avenues of kind of research possible. I mean, we've got these um, s- studies that are using 30 up to 30 devices concurrently with just a couple of operators, and that just really wasn't possible, back
Yeah.
in the days. So yeah, lots of new and exciting avenues of research, huge data sets being generated, hundreds of hours from many, many participants, right? And so how do you work with all of that data, crunch it to get insights? And I think that's also what we've been thinking about. If you can solve eye tracking and make it easy, then you are going to generate these big data sets. And that's the next stage. Like, how do you work with those? And so that's why we've really been getting into the cloud computing side of things, building up Pupil Cloud, which is our online analysis framework and kind of really good for data logistics. And within that, we can really leverage the power of cloud compute, right, to crunch these huge data sets and like help people generate insights from these massive amounts of recordings.
Yeah, I can only imagine. I mean, I know that even our cloud for our devices, we have also quite a few of them here, and they already need so much storage, and I can see like how fast you can kind of scroll. We see how your algorithm kind of go through our videos, and when they're long, I can only imagine when you have hundreds of these on the server, that is a lot of power. But you said like the advances in the last few years that you made, it's tremendous. And from our perspective, of course, the image mapping or reference image mapper, I think it's called, when I can show the algorithm what I'm interested in, and it searches through the whole video and
Yeah.
actually enables me as a, non eye tracking expert even to find things and to analyze how many people looked at this shelf, image, TV, whatever. I think that's for our applied research guest as well. That's super interesting. So if you don't mind sharing some of these from your website, or if we can also dive in and actually look at into the Pupil Cloud and get a bit more hands-on.
Yeah, let me just quickly try to share my screen so we can check that
Yeah, take.
out. Okay. Right. Mhm.
Yeah, I'll tell you when I see something.
Yeah, here we go.
There you go.
All
Yeah,
right,
I
so
see the
hopefully,
window. Mhm.
yeah, you can see my browser window. So Pupil Cloud runs in your internet browser. So you can access it from any computer with internet access, really, wherever you are in the world, which is really nice logistics feature, and collaborative feature as well. You might think that you can upload your recordings from one side of the world and have your collaborator log in and view them. It's really quite powerful in that regard. Um, yeah, the auto image mapper is something that Philip mentioned, and it's kind of a new enrichment, and it's turning out to be incredibly versatile and powerful. It's kind of like a magic wand. You can point at long recordings, and it seems to solve them pretty well. Um, I've got an example of a Lego box here. There's someone viewing it, so you'll notice they're holding it. They can move it around in their field of view. Um, and that's all great. So already we're getting a high level overview, right, of where or an ob subjective overview of where the person is looking. We have the gaze, we have fixations denoted by the blue circles, and we have your scan path showing the saccades between the
Mhm.
fixations. Um, so now that's great, but we might have like 50 participants who have done this exercise. And the last thing we want to do is go through frame by frame and manually decide at each frame where the fixation point is on that product, right? So we want to automate that, and we can do that with our auto image mapper enrichment. In this example, we just got two recordings that I'm going to show you. I'm going to go to here's one that I prepared earlier. Um, so you
Mhm.
can see on the left, we have the eye tracking footage, so the first person point of view, as we've just seen. And on the right, we have a photo or an image of the thing that we're interested in. And what the system does is it figure out a mapping, right? So it's mapping fixations from the scene camera of Neon, which is kind of moving freely in space, to this static 2D image. Um, and what you can do with that, so that's great. So you can see hopefully on the right the mapped
Yeah, yeah, we can see. Mhm.
fixations. So I can skip through fixation by fixation. And it will automatically determine when the person looked at it, and you can move the object and flip it around, and the front might disappear, but as soon as you bring it back, it remaps it. So you can load all your recordings into cloud, and it will crunch through them using the power of cloud compute very quickly. We might want to then generate some areas of interest. So we might want to like quantify, for example, how long
Mhm.
did the participants look at the different icons, the different aspects of the design on the packaging. So we can generate these quite easily. Again, these are some pre-made. Um, if you want, you can draw them freehand. So let's just do a little test one here and give you a general idea. So freehand, or you can do straight lines like that.
Right.
And once that's done, you can give it a name. So it's really intuitive and actually quite quick. And you only need to do this once for your product or whatever you're interested in. So we come out of there, and then we can look at some metrics. So now this has computed some kind of metrics that you might be interested in. We have a couple of different ones. I
Hmm.
think depending on the research question, what you're interested in, a common one that we see in marketing, for example, might be the reach. So the percentage of AI is within the recording data set that was fixated at least once. Um, we can look at time to first fixation. That's usually another one of interest, right? So you might have a new product design. You want to see whether a different placement of something on the product attracts attention quicker than the others, and so kind of you get the gist there. So yeah, for the sake of the demo, I just select average fixation time, and it shows up here um, in the little things. You can quite easily, so this is like an aggregate of those two recordings. So imagine you could have an arbitrary number of participants and you can generate these metrics on aggregate. You can also filter them down. So if you're interested in subgroups, say like pre-post or different designs, you can quite easily select which ones you want and they will go into the metric computation.
Exactly.
Um, yeah, so it's pretty quick, intuitive, and flexible
That's
as
super
well.
cool.
Yeah, a lot
And
you can do with it.
you don't need the markers for this setting then anymore, or I don't need to do like a reference image filming with
Exactly.
a camera anymore. I think that's super powerful. Like you said, like I can imagine many settings where we would like to give this a try, and I'm sure you have already and your clients have already tested it in various settings.
Yeah, exactly right. So there's no requirement for the old way of having the April tag or fiducial markers attached
Hmm.
to whatever you're looking at. It's always been a bugbear of some researchers they want to do away with them. Well, we've managed to do it. You're right. Reference image mapper was the other another enrichment that we have in cloud. Also super powerful, but it is a little bit you need to do the scanning and recording, right? So if you remember doing, you would film the environment,
Hmm.
generate the model, and then you would essentially achieve the same result as with this auto image mapper, but this auto image mapper is super easy to get there because you just upload your participant recordings and a picture, and that's it. That's all you need, right?
Yeah.
And again, we're trying it. It works in supermarkets on shelving units. It's working in simulators. It's working on packaging, books, menus. Signage in navigating a subway station or something like that.
Yeah.
It's really showing it. Like as I said, it's kind of becoming this sort of magic wand that you point at an environment and it does a mapping for you. So it's really nice. Um,
Awesome. Yeah, sometimes we also realize, okay, when we're not at the point of recording anymore, that we wanted to add something later on, and then we also had the problem, did we actually do a recording of this or not? And now we could be even decide afterwards
yep,
what
absolutely.
what we like to analyze. That is amazing, cool. And
Yeah,
runs in the cloud. Yeah, the visualizations and the yeah, fixations and time to first contact. These are all like you said for us marketeers, definitely interesting.
yeah.
And what else? There was something else. No, but now I interrupted you. Sorry. I wanted to I wanted to look at with you, but go ahead.
No, I was just going to say that you're right. Sometimes you're in a testing environment, you do the recordings and you get out of there and you can't go back. Actually, you can do screen crop an image like from the scene video and upload that as well. So we've done that in a couple of instances and helped our clients do that. I'm thinking of one in a real world underground navigation study, a whole bunch of data. And they could actually find the things they were interested in, take a screenshot and use that as a reference image. So everything's saved, no need to go back and recreate scanning
Yeah.
recordings and things like that. So it's great.
Yeah, there's actually a live question. I might as well just throw it in here. We also have this problem sometimes, when you actually do point of sale research with our for our shopper clients, and we always have the problem that the shelf, let's say it's a shelf with like 50 products and something, varies or changes, or a
Yeah.
product is gone after a day. Like how robust is um the algorithm? Like would it still find this shelf or would it still find the Lego box even though I change a little bit something on it?
It's a good question. So ultimately, the mapping does require a sufficient amount of features that remain the same.
Hmm.
So we've actually tested in a kind of a shopping environment where the products are moving a little bit, and so long as, I mean, to give you a concrete example, um, could
Yeah, take your
probably,
time. I know you have it in there somewhere.
yeah. Um, So this is a kind of shopping environment that I don't think this has been run yet, but in this kind of environment, it does work. You can remove some products so long as the shelving stays the same, and so long as other products don't change too much. We can do the mapping. If it struggles, we have a manual correction tool, so you can actually just
Hmm.
fill in the gaps manually. So let's say you might be able to map 40% of the recording, and the other bits don't get mapped because there aren't sufficient features. You can manually correct it. But we've just introduced another kind of fail-safe mechanism, if you like. It's not just that, but it can be used as that, which is the ability to generate a different enrichment. Let's say you have to go back to the store and take another
Hmm.
reference image because the things change too much. You can go back, take a new image, whatever you need, create a new enrichment, and then we have labels which allow you to compare those metrics across enrichments. So you
Oh wow,
can
okay.
still do
I didn't
your
know.
aggregates. Yeah, yeah, it's really, it's new, relatively new feature. It adds some complexity, but once you get your head around the being able to use them, yeah, they're really, really powerful. You can it gives you the opportunity to recover like that kind of data. You can also, let's say, have um, multi-site studies, right? So you might want to investigate one product, but at two different locations because you have two teams running.
Wow.
So they can do that. One could be on in literally on one side of the world, the other team could be anywhere else. They all upload to the same workspace. Um, you create two enrichments and then you link them together with labels, and then you can treat them all as one study. So that's really, really nice, really powerful.
That would
Again,
be
yeah,
it's a new thing, but I'm sure since you do your documentation so well and bring everything online, I'm sure since there was also a question, is it already documented? And I also, sorry that we kind of jumped right into this. There also was a question of, how do the recordings get to the cloud? And I skipped that part, that when we record the recordings first, they will land on the companion on the Android device, and then if I'm already in a Wi-Fi and I have it enabled, they will automatically be uploaded into this secure workspace where only the people who are allowed to enter the study. Sometimes it's just us, sometimes it's us and the client actually can see it. And this is also where we anonymize the data since we're a German company. We always talk this through as well. Like if we anonymize the faces and then
yeah.
we'll run the analysis, and what we get out of it, the aggregated data has nothing to do with personal identifiable information anymore. And so that was also one topic, how where's the data? Is it like in a cloud somewhere? No, this is all part of our job. Like if we work together with Pupil, we have to make sure our security standards match. And I know they match since we ask you a lot about your information security standards. But that question, yeah, I also then touched it. Sorry.
Yeah, yeah, absolutely. So yeah, recordings are initially stored on the companion phone, like you said. You can make a single recording for up to 4 hours. We can go even longer sometimes, and so yeah, loads of potential to store on the phone and play them back on the phone. But then, as you rightly said, as soon as the phone has internet connectivity, um, you can choose, you can enable auto uploads and they go to the workspace that you want. So you can set up different workspaces, and you can treat them like sandboxes. So you can have one
Hmm.
workspace for one study. You might have a different client or team doing a different study, and you don't want them to have access to everyone's to each other's data. So yeah, you sandbox it, and you can
Hmm.
give only the intended people the relevant privileges to be able to log into cloud, to upload to cloud, and so on and so forth. And we have different um, privileges. You could just grant them the ability to look at the recordings like a viewer, or you could give them edit access, or you can even make them an admin. So there's a lot of kind of possibilities there. On the topic of data privacy and security, yeah, we treat that very seriously. We are fully GDPR compliant, and we adhere to all of the rigorous industry standards that go along with that. And we can um, we have face blurring as well, like you mentioned, on
Hmm.
upload, so we can anonymize anyone that appears in the scene videos. So yeah, a lot of the data privacy and security aspects are covered. We take seriously.
That is super, super helpful. Since time is running, and I know it's already late in Hong Kong as well. You would you mind maybe that we have like a look at something else, maybe something of the futuristic parts of the Alpha Lab, since I think that's something people rarely find. I think you first have to go to like your documentation part of the website, and then that's how I go at least when I look for the
Yeah,
Alpha Lab, or you can find it if you're signed up for the newsletter.
yeah. So this is our online docs, and you'll find everything you need here to get familiar with all of our tools and how to use them. If you find this section called Alpha Lab, this is a really nice area where the product specialists and the R&D team get to play around, build stuff, as I was mentioning earlier, connect our technology with other tools, with cutting edge tech. Um, we've built up quite the corpus of Alpha Lab articles here. Um, Word of kind of something to bear in mind. This is an experimental area, so it's not official product or tools, but rather really can think of it as like here be dragons, very powerful stuff in here. But so some examples we've got how to use eye tracking with motion capture. Um, Motion capture kind of manufacturer agnostic as well, right? So this could be used with all your big manufacturers, your Qualisys, your Vicon, your BTS, and so on. So you can see the 3D person walking around and the 3D gaze ray from Neon projected into the 3D motion capture space. Um, we're really excited to see how people use that. We've already got a lot of clients and users sending examples of what they've been up to there. We have this is a really nice article that was written by Miguel, a member of my team who's quite technically gifted. This shows you how to essentially run computer vision algorithms and map gaze onto anything. So he connects this tool with he connects Neon eye tracking footage with YOLO models. You can see the
Hmm.
basketballs getting tracked. Um, this is like another segmenting model. Uh, Pose
Amazing.
detection, heat maps. This is like depth. So it's essentially any algorithm that you can find on the internet that can interpret the scene video, right? So scene understanding and recognition. You can essentially connect it with Neon eye tracking footage, like face detection, Google Media Pipe. Yeah. If you can think of it, you can find it. There's a way to connect it to Neon using Miguel's scripts. So he's written some really cool um, open source Python scripting that you can download, adapt, and
Hmm.
tailor and tweak and so on and so forth. Um, yeah, it goes on. We've got lots of things in here, how to use GPT um, to understand events that are happening in the scene footage. We have uh, how to use eye tracking with GPS, so measure someone as they've been around in their environment. Some more of your kind of uh, behavior detection things, like how do you look at percentage of eye closure over time and use that in real time. Um, yeah, there's just so much in here, but yeah, I would highly recommend if you're interested in this kind of thing to go and check it out.
Hmm. Yeah, there's definitely lots. I remember the one, I don't know if it's in, was it in here as well, where people were all sitting at this same time in a, was it a concert or like a movie theater, and the researcher mapped all of
Yep.
their parts in one. I know one of our consultants has seen it and he wanted to adapt it right away for one of our media clients in research. And I also said, no, actually, I think this was more of an alpha lab study, but it's possible to do it. I mean, that's what it's all about. Yeah.
Yeah, so I think you're referring to a project called Socialize. Yeah, so they used, I think, upwards of 30 neon systems
Hmm.
concurrently to measure the audience or record gaze of audience members watching a live performance. So all of the systems were synchronized in a very impressive way. They've kind of built upon our real-time API to do that. And then to map gaze, all of the gaze onto this
Hmm.
performance and had this kind
Yes,
of dynamic
that's
3D heat map. Yeah, which is really an amazing thing, and it just goes to show like what is becoming possible
yeah,
with eye tracking and technology.
yeah.
Um, yeah, we do have some kind of similar approaches yet to be released in Alpha Lab that will show you how to control like multiple eye trackers concurrently over a network, start and stop them, send
Mhm.
synchronization events, and so on. That's
That's
actually
good.
coming soon, so watch this space.
So I'll definitely keep keep people, yeah, updated. And so please go ahead and sign up for the newsletters. And on Discord, you are also very active. It's also interesting to follow your discussion there, and our researchers as well. Like they become more creative. Like for us, the second screen research, I think couple of years ago when it started, when our clients wanted to understand how the large and the small screen interact together in a natural environment. And we said like, okay, we can do it, but we will also need the help of, of the pupil team to make it possible. And that was also super interesting. That's a challenge, of course, when the screens, of course, change and show um, different part of content to still be able to detect it. I think like like in the early years, we always used the markers. They're basically black and white markers, like you can see here
Yep,
on the
yep,
screen. And now this is also, yeah, possible without
like this
this.
kind of thing. Yeah.
Yeah,
So
exactly.
yeah, it's always been tricky to get without the marker's gaze accurately mapped onto 2D screen content. Um, yeah, so this is another example of one example of how to do it that you might want to check out. Yeah.
Yeah. Well, thanks so much, Neil. I think maybe we'll just have to invite you again, and don't want to keep you too long. And thank you so much for dialing in here in the evening, and send best regards to your pupil colleagues here in Berlin. And I hope then we'll see each other again soon. And just for the participants, thanks actually for staying that long. And we'll send an email around with all the information that we talked about and also the contact information. And then we wish you all a great evening. And yeah, thanks a lot, Neil. Did I cut you off, or did you forget, or do we forget anything that you wanted to mention?
No, I think that's sufficient. Yeah, thanks for the inviting me on to talk, Philip. It's been enjoyable, and I would say if anyone does have any questions, yeah, feel free to reach out to Philip or myself if you have the
Yeah,
email address. We'd be happy to respond. Otherwise, yeah, enjoy the rest of your respective days.
we will. And thanks so much for your time, Neil. Take care.
Okay, bye bye.
Bye bye.